All right. Well, we can get started, I guess. Well, a couple of people probably still rolling in. But welcome everybody to yet another iteration of the Open Game Via Open Office Hours. Just as a reminder, the Open Game Data Community is an NSF-funded research incubator looking to bring together a collective of researchers interested in the use of data generated in and around games to advance our scientific understanding of thinking, learning, decision-making, human psychology broadly construed. And we have two primary goals with this community. So one is to compile a collection of resources, best practices, thinking about how people use data with games to do science. And then long term, we're looking to build some actual hard infrastructure that encodes a lot of these best practices and makes it easier for new people to do this stuff, makes it easier for us to share our techniques and approaches across each other to further advance the science of working with games. We have a bunch of resources already in the Open Game Data community. So there's the Open Game Data website, hosted Field Day Games, which shows some examples of code that's available and games that can be tried out. We have an Open Game Data Slack that we use to coordinate among the community. And then we have these Open Game Data office hour sessions, like the one we're having today, where we are collecting a bunch of worked examples around this kind of work, recording them, and making that available to the community. So how these sessions work, they're inspired by a set of sessions that the Statistical Education Research Group used to do at Carnegie Mellon, where somebody, usually a grad student or a postdoc, would present on their work and then publicly workshop with one of the members of the stats faculty, who would raise things like, have you thought about doing this? Or what about this question? Or show me your code and let me see if you're actually writing in the right regression model or something. And as an audience member in those sessions, it was super useful to see sort of how do experts think through this problem. How do they approach these topics? And so we're doing the same thing here, but focusing on game data, statistics generally. Some things to keep in mind is the presenters are generally going to be showing work that is in progress. So some things might be very sketchy. They might be just new, fresh ideas. And so we want to be conscious that sometimes that takes courage to do and considerate that these things aren't necessarily going to be polished. Our goal here is to help the presenter understand their problem, make progress on their project, help them achieve their goals, but also these sessions are about learning for everybody involved. So if somebody raises an idea or a question or something and you don't know what that means, feel free to raise a hand and ask for clarification. Or if you have a suggestion for the presenter, feel free to raise your hand and do that as well. And with that, I'll hand it off to Dave, who will be our presenter for this week.
Awesome, thank you. So this is going to be some very work in progress stuff today, but I think that's what I like about these meetings is it's actually like I'm not coming here to show off. It's like coming here to like really get some help. Let me make sure I can do this. The slides in the portion of the screen. I made a shift just like right before we started. Okay, are you seeing a slide now?
You're seeing slides, yeah.
Okay, perfect, cool. So yeah, here's the project. We're working, our whole team right now is really getting on board with replay. And I saw that I think we've got a perfect audience for this one today because between Erik's dissertation, which believe it or not, I've been reading. And then Elizabeth Rowe, I saw you're here too. This is awesome. I'm hoping that we can have some good conversations around like the use of replay. And I'll kind of set up the context of where we're using it, but I know that we've got some expertise in the room, which is going to be great. So here's the project. We have a NSF-funded ASL, so an informal learning project around polar research. So this is research that are happening at the North and South Pole. And I've already presented on one of the projects that came out of that, Waddle, and showed how we did that study around empathy and embodiment. And we'll be talking about that one a little bit today because it's the one that's kind of done. It's in the wild. We're collecting data on it. So it's kind of the test bed for the kind of work we want to do with the other ones. So in total, we'll have 5 of these experiences, Waddle being one of them. And we just finished up a beta for the next one that I'll show a screenshot or two of here in a minute. And what we're really noticing is that we are not great at doing usability research with VR. I think it's just harder is what it comes down to. So put this into context, we're building things iteratively that we want to have used by a public audience. And anybody that's ever built games or interactive systems of any sort know that you just have to watch people interact with it in order to figure out, how to iterate and how to change it. So we really feel blind going into these projects because we're just not getting the usability data we normally do when we do a desktop game. So a little bit more context. The first one, Waddle, and the one that we'll be spending the most time on today is a project where you directly embody an Andeli penguin. So you have a beak that sits out in front of, kind of right out in front of your nose, and that's the one way you interact with the world. And then you have flippers that replace your arms when you look down, and that's another way you interact with the world. And to move around in this world, you waddle back and forth, and that gesture of having your whole upper body move is what kind of advances you in whatever direction you're going. And we'll see a video about this one in a minute. But the newest one, I'll show you just a clip from. This one is modeled after, here, and I'll.
20 knots, easy peasy. I could fly through that with
I wonder if I can turn off the audio of this while I'm doing it.
It's open,
Oh, here we
would be
go.
better if you don't mind.
Okay, so in this one, you are you're someone who's working on these weather stations that are positioned all throughout the South Pole or South Pole area in Antarctica. These stations are solar powered with a battery. Then they have an uplink with directly to satellite for data. And it's how we build our worldwide weather models is by having dozens and dozens of these spread out through Antarctica. So we were lucky enough to get to work with some of the people that fly down there to use the McMurdo station as a launch pad, and then go take helicopters out and cool like tank kind of vehicles and stuff. And they go and they dig these things up and they repair them. And so we built a kind of a job simulator style game about doing that, where you go diagnose it, and then what we're going to see right now, you take these components back into your airplane. Oh, I guess that's at the beginning of it. Oh, here we go. And you work on them and then go set them up again. So those are the two games that we're in the context of doing right now. And again, both of those are finished. So we're like just pivoting onto a third one and really trying to make sure that these are performing well. So here's the problem. This is what usability testing looks like for us with these VR games. We end up at these like festivals and libraries, and there's just a pile of people. And it's like, it's so hard to pay close attention because you can't see what someone sees in VR. You have to cast it to an external screen, and that reliably doesn't work very well. Like it's like every time we have problems with it, like every single time. So what ends up happening is, even if you've got a very controlled environment and you're trying to schedule people, it's so costly, it's so time consuming, it's so noisy. The whole process of doing usability with this is just harder than opening up a Chromebook and hitting go. Okay, so in our first pass through this, we were just using game telemetry, and we started creating some visuals like this one. This is like a top-down kind of heat mappy version of how people navigate the space in Waddle. And then we started playing around with some signal processing and thinking about, what we could get from just the raw signals of, hands and head mounted display gaze. And this one, we played around with the idea of a dot product. So like, how rapidly are they moving? Like, how chaotic are their movements? And then we started playing around with these kind of 3D gaze visualizations. So this is all kind of one line of work, is like, how do you visualize these, complicated 3D interactions in easy ways? But what I want to focus on today now is really getting into replay. So we already had open game data. So we already had, a Unity client and a back end and ways to process and everything. And with really minor modification that we've already deployed out to the Unity client, we were able to support just adding really large chunks of data in the event data stream. So we created 3 new events for this game in particular: viewport data, left-hand data, right-hand data. And if you look at what they contain, it's really simple. It's just a JSON formatted array of positions and rotations. So we wanted to kind of proof of concept this thing and see if how that would work and what kind of issues we'd run into. So I think right now we're running at 20 frames a second. So we send 20 samples in a package, and we send that package every second. But there's been no issues with data size or anything, even in this very verbose JSON formatted way. Like it doesn't look like it's going to be a concern for even modest network connections. The other thing we ran into right away was that the way that we're approaching replay is by recording the input signals, as you can see, like how the user is moving, and then really the goal here was let's just stick that back into the game engine and pretend there's a user there, and then the game should just play out the same way it did. And that mostly worked, except for at the very end of Waddle, like the last activity in there, there's a time where you've got to defend your nest against the skua birds, which are a predator. And we used random numbers generators to like move them around and figure out where they're going to go. So again, really simple solution is we just added another data member to the session start event where we passed the random seed that Unity was using. And lo and behold, it works great. You replay the same randomness. So for single player deterministic simulations, this seems like it's going to work great. So we created a Unity package for this Open Game Data Replay, and it's a module that I think you can also get this off the Unity Package Manager the same way you can the Open Game Data Telemetry client. And it's really easy to set up. You basically just for playback at least, you just pick your objects in the hierarchy that are going to be controlled by this replay stuff. So the gaze kind of camera rig, the right hand and the left hand objects, and then it just hooks it right up and plays it. Pick the script and hit go. You also can specify a whole folder for batching up a bunch of these replays together. The way we approach it right now is that it plays back the signals into the game engine and then generates a video file as the output, which is just much easier to move around, but obviously has a lot of issues. It doesn't really matter what the video file is. Like if you wanted to play back a different camera angle or some other scene or multiple cameras, you could do that, but we haven't yet. So practically, I'll give you like a little demo of what this looks like. So here's a video recording right off the Quest headset to get an idea of what the interaction looks like when you're just recording the frames right from headset. And that looks like this. And then for reference, then here is a replay using only telemetry at 20 frames a second, back through the game engine, and then the video clip that came out of that. So it works great. It's surprisingly effective. You might have noticed that the frame rate there was almost too smooth, and that's because we do like an interpolation effect to smooth out those 20 frames a second. Okay, so that's the context. It started with a little bit of like, can we build it? How hard is it going to be? What is our lowest kind of like proof of concept demo? And that's where we're at. And all those packages are all up on GitHub and easily used. So we're moving toward now using this across all the games in this package. So really, I think there's like kind of two questions that we had right now, which were first off, like, can we use replay to help with usability? Like, does it help if we get this running? Because unfortunately or not, I end up being a gearhead sometimes and just like building things because building things is fun. So the first part is like, does it help anybody? And then the second question is, once we've got it running, can we use automated methods like others have done to do detection of interesting phenomenon that we see while watching replay? So can we automate that process? And can we do it around usability? So as soon as we ran a batch of these, we didn't even do a formal process. It was like as soon as we ran the batch and looked at video files, Kevin, who was the one kind of getting this to work, immediately saw 3 usability issues, like without any formal process. We found that players would try to pick up a rock with their hands or flippers, which isn't allowed by nature or the video game. And then the other one we saw is that players in this first scene of the game would pick up a rock that you use to build a nest, and they would walk away from the target nest where they were supposed to be building and just go like wander off somewhere with the rock, not figuring out what to do. And then the last one we saw is they'd pick up a rock and then they would keep on pecking at other rocks to try to pick them up, not understanding that you can only have one in your beak at once. So based on this, we went through the next question of how would we create a detector for this? And as much as we probably could have got it to work, given the telemetry that was already in the game, we decided to make our processing a lot simpler and just add a couple new events that captured some of these states and deploy a new version. So we did that. It was a really minor change. We added a couple events and then put it out onto the Meta Store again, onto App Lab, and waited for some more data to start rolling in because we've got kind of an audience that's already out there playing it. So first pass on this was that if you do a histogram of these 3 features that we end up having, they're these detectors of these behaviors, we see that it's kind of an interesting pattern for all of these. You have the vast majority of people don't have these problems. That's the kind of big graph at the 0. That's the number of times they ran into these issues. And then sometimes you get a little bit of like a curve of people that have the issue a few times and then figure it out. But often what you saw is counts of like 57 times they tried picking up the rock the wrong way. So it's like just repeating it over and over and over and over and never figuring it out. So those pop up later in the histograms. So the interesting thing about this is I think it answers our second question, or it's really promising towards that second question, which is like, can we create automations now once we've identified these patterns? And it seems like absolutely we can. And we can calculate how often each of these issues is happening and how many users it's affecting. And that's really fantastic for helping us prioritize how we want to approach these usability issues. So all the data sets that I'm talking about and the features I'm talking about are, including this replay stuff, is all live on the Open Game Data site. The new features we just added, like just added, aren't there, but they'll probably be in next month's data dump. So you'll be able to play with these too. Okay, so I've been yapping for 20 minutes already, and I want to get to the office hours part of this, where I just need your help. So we've got a couple next steps, and I'm hoping to dig into 1 or 2 of them kind of in detail. So our first next step where we've got to go is getting hands in the system, and we just don't have it. Waddle just didn't use gripping motions. You just had the flippers. So we didn't have to do it then. We're going to have to do it now. I'm not really sure how to do it because there are just a lot of analog buttons and I'm not exactly sure how to think about it just yet. So if we have time, we'll come back to that. But then the big one is rendering out to video is obviously non-optimal. We have to do this in real time. So one 20-minute session takes 20 minutes for Unity to boot up and render. So we've just basically got a bunch of shell scripts running on a VR development machine. And we've run like, I don't know, hundreds or at least 500 of these so far, where we just render out the videos and stick them somewhere. But it's so slow. So that's the topic I want to come back around to here. I really want to start thinking about an annotation system, and I would love it if we can find some examples of things to pull from. I know that Edge at Turk has one, and I know, there's things like in Vivo and such that have been around a while, but I'm looking for design references for those. Obviously, multiplayer is an issue as well at some point, but it won't come up in our games. So kind of first question for the group is like, what are some of the other big directions we should even be looking with this idea of replay? Like what are some of the things that you've heard of or papers that you've seen that you think should be on our radar as we're kind of planning next steps?
So when you mentioned all the data is available, is the replayer available too?
Yeah.
And that's a Unity project? Or is that a compiled out thing?
It's a Unity module you add to your game.
Okay.
So in this case, the Penguins game we added those 3 events I mentioned, and those are just regular events. And you can see a sample of that if you go look at the Waddle project on GitHub. But then to play it back, we just added the Open Game Data Replay module. It's a Unity package that you can add in, and then hook up those.
I'm free in 30 minutes, Mike.
Oh, okay. All right, I'll pass it with you later.
It's super
Yeah.
easy to wire up is the answer. And then, yeah, there's like a button right in the Unity menu for rendering out replays and picking which data file you want to use and all that.
And so is the idea here you hit go and it renders out a video?
Yep.
Okay.
That's how it's set up right now.
Because I was thinking, like, for the annotation system, do it in Unity as part of the Unity tool, which is a thing I wanted to eventually do with my replayer, but never got around to. Because the authoring, how do you express a query on a replay? This complicated thing in 3D. But I think given that you're doing data replays, I think there's a lot of affordances you can play with here. Like if you're like, I want to know when they get to region X, you can literally just put the collider in Unity and fire when the trigger fires. And or if you want to see, like, are they paying attention to these particular objects, you just like switch their materials to like bright magenta, and do they show up in the video or not? And so like you can play with the fact that all the stuff is there because you're in engine.
That's right. Yeah. So like we have already done the ray tracing kind of like gaze object, and can spit out, like an event now based on that. So that's one of the other cool things of replay is like, even if you didn't build the feature in when you set up replay, you can replay it, in engine and then create new features like that are complicated like that. So yeah, that's already been a really exciting possibility.
So, hi.
Hey, good to see you.
Well, I'm not in position to be seen, but you'll have to deal with my image. But I will say that we've done all of ours in Unity, and we've done, I think, steps 2 and 3. We've done a kind of multi-version, but we've done a game that switches perspectives. So the players switch. I see you switching between players in the same way, in the same replay, so that you're. I will say that it's super useful instead of just a video. It's what I think what Erik was alluding to was that everything is tied to those events that we have. So it's scrubbable by it's by round, but it's scrubbable. You can link to very specific events and highlight them and tag just those events. And you can just select which one. So what we haven't done is select which ones you want to see. Like I've already done that by default. It's always our events. But you could probably say, and then we've overlaid eye tracking on top of it. So we have an eye tracking signal that floats along with whatever they're looking at on the screen. Now it's a little bit more difficult with VR. But
it might be a lot easier actually.
Yeah. Some VR headsets just have eye tracking built into them.
Yeah. This is very cool. Very cool.
I'm curious actually, Liz, what frame rate are you collecting your replays at? Because I would think 20 hertz is probably not sufficient for an eye tracker.
No.
Right.
Or are you doing like really gross eye tracking?
Right. So for that game, which is Impulse, which is that we were much faster. And we had to specially rig it up. We use lab streaming layer to do the connection. And that's actually part of what we're going to be building with Safe Insights, is a way to do that. With very specific eye trackers and linking up to, but that game had very rapid data collection anyways, because the movement of the objects was very fast. Zumbini's, I think, is much less, and so our collection rate is lower. But we don't sync eye tracking yet. We're going to get there. That's part of Safe Insights too. Yeah, but this is but we had our game developer use the artwork and basically the data structure and recreate the game in reverse, what David was saying at the beginning. So it looks exactly like the scrubbable version looks exactly like what the player saw.
Is
Yeah,
it?
so let's get into the details of that a little bit, because we've had a couple like office conversations about how to pull off the scrubbing, and the metaphor so far that has taken us the farthest has been that you think of it like keyframes in a video, where you basically do snapshots of the game state and then deltas on it, and that something about that just sounds terrible to me. I'm curious if there's some
No,
other
Why?
ways
So-
to do it.
no. So I think it's more like what you described at the beginning. You have all this telemetry data that is about how the player is moving. We also collect a lot of information about the game state itself. So what, which Zumbinis are in and what characteristics do they have, because that matters for what solutions the kids would pick. And so we collect and also what the solution is. So we know in advance in the telemetry data what will work and what won't work. So then we basically recreate the game using that code, and you can watch as it unfolds exactly as the player played it. Does that
Oh, I
make sense?
see. You
Mhm.
have a whole different Unity project for replay than from the original.
Right.
Yeah.
Mm.
Right. But it's definitely it's fine grained. You can
Yeah.
go as our annotation system is tied to those events. So like it's for Zumbinis, it's pick up. The player has to actually do something. So like they pick up a Zumbini and they drop it, or it crosses a bridge, and then so you can only label time between player actions as something.
Yeah. Okay.
Mhm.
Yeah, like and we ended up labeling a lot of things by round. Like we saw like what you were describing before about the picking up the rock. That's really good process information, and we would say that's kind of like a trial and error type of thing. And you label the whole round as kind of like, this is evidence that they really didn't understand what they were trying to do with the rock, right? They were struggling with it. So instead of a histogram, we would do it as more of this is an annotation for the entire round of play. So something that we're seeing, but we do that human coding.
Yep.
I know Erik probably would prefer to do it automated, and you would prefer to do it automated, but we build automated ways from the humans.
Yeah, that's kind of where we're heading with this, is humans to find the patterns and then machines to find them at scale.
Yeah.
Yeah.
Mhm.
Right.
Yeah, the way that my replayer worked is similar to Liz, where mine was still in the same Unity project. It was convenient. It was a puzzle game, and every level was basically the same proto scene, so I could run stuff through it. But so I had a dedicated scene for my replayer, and all of my events were full state, and then the event action. And so, for example, like you were saving seed and then replaying the seed.
Yeah.
I would just record where all of the monsters are all the time.
Yeah.
And then I don't need the seed. And that's mainly because this was a physics-based interaction, and physics is documented non-deterministic. So interpolation's not going to work if you're relying on the physics.
Yeah.
It'll start to fall out of accuracy eventually. And so we needed to do essentially the keyframe thing is what I did. Where it's the keyframe state and then a forward event. You could think about if you're worried about volume of data for that, which totally get that. You could think about having like a slower heartbeat keyframe, where it's like every second or every 3 seconds or something, just so that because essentially what you're doing for a scrubber is it's an indexing problem. And as long as you have something to latch onto to be the key, and then you interpolate from there, it's not as much of a nightmare. But yeah. It is a bit of a nightmare.
I'm really thinking towards reusability, because we know we're doing it for the next 3 games. So it's like, it's always nice when you have to stamp a thing out, and we kind of know the shape of the next couple games, roughly. But I'm really hoping that we can come up with something that's like in perfect world, you would just like put a label or like a tag on objects in the hierarchy and say, these are replayable.
Yep.
And
So,
then it would be included in the state, and
Yeah. So to give you another example, a project I've gone on to do from my replayer is this this Twitch overlay extension system where we send data out to Twitch and it can render it on top of the video. We literally use keys and tweens as a first class concept in that system. So you attach a mono behavior, and either it records at a key frame rate or a tween frame rate, and then you override that to say what is in your keyframe data, and that's like exactly how it actually records itself. And so you have the keys and the tweens. We're starting to hit the point. It's like, do we really need both in our particular case?
Yeah.
But yeah, it's essentially you would just attach an object to it and say record everything that you would need to grab out of whatever mono behaviors are also attached to this thing goes into state, and record that. So you just have to override one function per major prefab in your world, and then it just registers itself to a recorder and everything automatically and all that stuff. So that's how I would build my replayer now if I were to rebuild it. Is you essentially have this trackable that you can just turn on.
Yeah, it's just a trackable parameter.
Yeah.
Then it's interesting now that we've got, you know, like Liz's work and that really was doing things in a separate from the original game engine. And I'm kind of curious pros and cons of that. Like in practice, how's that worked out? Because that's a possibility too, is that we build like some sort of replayer as a separate tool. And I don't know how that would work exactly, but it would be like you're almost using the. Yeah, I don't know how to automate, or not. It's not automate. I don't know how to replicate that or like get a lot of reusability out of that. Because it seems like for every game, then you have to build the game and the replayer for the game. But
That's what we do.
does it has that had advantages?
Well, you get completeness. You get everything, right? There's no, the timing is exact. Everything's exact. There's no interpolation of anything. So it allows us to be more, so we're not trying to do real time yet. I would say that's a real, you can't do real time with that model. Because it does take, you can't do it, you'll always be around behind the way that the data collection works.
Oh, okay.
Right. So the game is playing, the player's playing, it sends data back up to the server at the end of the round, then we can access it through the replayer right away. But it's always going to be delayed. It just allows our replayer, our tagging allows multiple people to do it. We have reliability analyses in it. So we have other things that make it worthwhile for us because of the types of analysis we do. But I can see where if you want real time, it's going to be really hard.
I haven't even been thinking about real time, but now that you've said it, now I want that too.
Well, but I think if you set it up, so I think there's a distinction between if you're building the replayer in the game itself versus two separate Unity projects or whatever. I think that's more a how do you run your engineering team question than how do you run your analysis. But if you do the keyframe thing, you should be able to run it in real time because you know the context of any event.
Yeah,
automatically. It's you can index into anywhere within the video, within the replay, and no context. Now, if you want to know cross multi-event context, then yeah, you need to know how to define that window. But that's one of the benefits of not relying on interpolation is you can index into anywhere. So if you only care about certain if you only care about like the rock pickup events, you don't have to run the whole video. You just grab the rock pickup events, throw them back into Unity. You know everything that's going on now. Calculate whatever you want, pick out an event, or run it for 5 seconds or whatever from the events.
So I will say that at least for us with the types of things that we're labeling, so like computational thinking behaviors, for me, what happens before and after those rock events would matter. And so for us, I don't think we don't want to separate those things out. We want to see them in the context of the whole round of play, so that the fact that it's the 50th time that kid did that
Mhm.
is an important piece of information. Now,
Mhm.
yes, you could automate that, but I think that when it's not, I don't know how to express it, when it's more complex concepts, like we had a lot of features underneath our game, our running underneath the game that we then used to build detectors of the things that we were labeling, because the things that we were labeling were more complex.
Mhm.
So like as an example, like the pizza pass puzzle, which I think, Eric, you might be, I hope you guys, they're basically trying to figure out which pizza the troll likes, and there's a set of toppings. So one of the things that we were really interested in is whether or not they repeated the same pizza, because that's kind of a mistake. Because they've already gotten the information for that particular one. But the pizza itself, what that picking that particular pizza means depends on what pizzas they've done before.
That makes sense. Yeah. Yeah, I'm totally with you on that too, that all the telemetry is already there. And we started thinking about telemetry with replay in mind as well. So it's kind of like a thing that Luke and I will say is, if we have nailed the telemetry, we should be able to do replay just from it. That means we're really capturing all the actions and system responses and all that. So that whole feature engineering and telemetry layer is happening, I think, irregardless. The thing that's been new about this is that normally in that telemetry, we haven't had to deal with, well, what renders out to 90 frame per second head movements. So it's like that was the new thing here. That was like these crazy amounts of data around movement and positionality and rotations and stuff.
Yeah, we had similar with the eye tracking, adding that kind of data on top of the game data. The synchronization is rough.
That leads me to another question that I really had for the group here, which is, are you aware of any projects that have added in audio recording or audio transcription as like into a telemetry or replay project? Because I feel like we constantly bump against this idea that if we had richer kind of talk events around our gameplay, specifically this VR stuff, that it would really help. And there's like a whole host of technical and ethical concerns there. So I'm curious if anybody else has already gone ahead and failed in some of the ways that one might fail.
Do you mean like speak aloud while they play, like why they play this move, why they play that move, something like that?
Exactly. Or if people are playing together, to hear them talking with each other.
So I think I've mentioned that we did this with ScreenFlow. We use ScreenFlow to record them playing the game that's also capturing their telemetry data. And we ask them to think aloud. But they're not, they're not synced. The audio transcription is not synced. We do the syncing manually. So that's a very basic way, but it's not what you're looking for, I think.
Yeah, I think the biggest issue there would be kind of the clapboard problem of how do you get the initial some event that you activate in game that also makes sound that shows up on the audio transcript to know where they give them a common zero.
Because we're in VR, we have to. The assumption I've had is that it's all coming from the game. So we've got code running in the game that's doing the audio recording and transcription. Right. So we shouldn't have a time issue. The synchronization should be there because it's all running in one timeline.
I don't know if anybody that's done. Well, I could maybe ask around because there's people around here that have done those kinds of like sensors in classroom type of stuff.
Yeah. Which
has its own host of insane ethical problems. Because everybody in the classroom has to consent. But
yeah.
But like I've seen things like that more done like in like a lab scale, which makes a lot of sense.
Yeah.
But I think it's usually they have audio and then you would record it to the video. But like you could be doing snippets of audio, sending it out to a speech to text thing and inserting the text into the log trace.
Yeah,
as
there's a model
as a
that
speech event.
I think OpenAI just released a audio to text model that will run in Unity on a Quest.
And I think those models have only recently gotten to the point where you could do that.
That's right.
Feasibly.
Yeah, that's my understanding, is that that's
In
really
real time.
It's really leveraging the idea is that you've got this thing strapped to your head and it's got like 10 cameras looking out at the world and a microphone. And can we do anything interesting with that? I know we're outside what we could distribute openly, but even recording the way kids are interacting with each other, or like someone mentioned, like Jimmy mentioned, just prompting them to think aloud, just like we do when we're on Zoom calls with our desktop games. It seems like that'd be a really rich data set.
Having them play in pairs is a natural way to have that come out.
Even if it's not a multiplayer game, like I feel like I've seen the one kid is observing and one kid is playing, and then you keep them talking.
Or if you're running this in like museums and libraries and stuff, like a kid and a parent.
Yeah.
That probably similar dynamic.
So when you're thinking about the OpenAI transcription, you still have the actual recording, right?
It's a choice. I would imagine that from an IRB standpoint, it would be easier to get talk events that don't have the audio. But I think from a research standpoint, both, if we're already consenting and stuff, then I'd want the audio.
Yeah, might as well.
All the intonation.
It's a question of how reliable is the AI for kids.
Yeah.
And their speech patterns and the language, and different groups of kids. Because I've tried using that for a couple of things, and I don't find it I have to go back and refine it afterwards. I can't just totally just rely on it. But so yeah, if you're already consenting, you may as well.
You may as well get it, yeah. And then just recording it on the headset solves, and sending audio data along with event data simplifies that there's no systems that need to be synchronized with each other. Just put the headset on and you're capturing all that at once, which sounds really elegant. The transcription thing, I think I've got a not so secret hope that there's some version of an IRB exemption that we could still get through if we never record the audio, never send the audio, and we scrub it for anything identifiable before it hits the network. I've got some little hope that I can get an IRB exemption that still has all that rich talk event data coming in. Anonymous.
Yeah, I think it'd be a bit of a stretch. If you have audio, so you're saying you'd throw the audio away essentially, and you would only
for like a public version of it where we'd still be IRB exempt because we only would be looking at the transcribed words with some protection that no identifiable information could even go across that line. That we would sterilize the data.
It'd be hard because like if somebody says their friend's name, PII's in the data now.
Yep, you got to pull out any name. You got to pull out anything that sounds like a phone number and address.
Yeah. Valiant effort. I mean, so like the class recording project here, they do that. They destroy the raw data, and they only look at process features and stuff. Partly for volume reasons. That's a lot of data. If you just essentially have a recording system running in the classroom 8 hours a day for a semester, it's too much to hold on to everything on top of all the identifiability problems. And they needed to get special dispensation from the IRB to not have to retain data for 3 years because that's the usual requirement. But yeah, you could try. I think it'd be hard. But at that point, you might as well just like if people are consenting it anyway and all that. So you probably wouldn't be able to release it as easily. So that's an interesting question. If you want to do those kinds of utterance things, they probably can't be open.
Yeah, and we already do that. Where like some of the data is open, some of it is protected behind, IRB. for one particular population. So that's already kind of,
Mhm.
that already happens, but. Liz, I'd be really curious if you have any screenshots of your replayer tool that are available somewhere, because I haven't ever seen it in any of the papers that I've read from you.
So we have a chapter in a book on innovative ways of using technology in education research, something like that. And that one has pictures, screenshots of the data, of the data arcade replay tool, and I think we might have a screenshot of the eye tracking. I can easily share those with you too. I can also give you a demo. I'm happy to give you a demo.
Yeah, maybe
the
that's
tool
how we
itself.
should approach it, is just to, maybe I'll set up a time with you just to demo it and see what we can glean and learn from what you've already done here. Yeah,
Free in 2 weeks.
Yeah, there you go.
No.
Actually,
I'm not in 2 weeks. I'm traveling in 2 weeks. But
Okay.
Well, the bigger thing that makes that funny is I think what Eric's getting at is we need some more people.
We need somebody for next
we
session,
need people to present at these.
yeah.
So we could make it one of the, if you're willing, we could make it one of these sessions where you just do a demo and show us your replayer tool. And
let me look at my calendar, and yeah, just not 2 weeks from now.
Okay, cool. Yeah, that wouldn't be that'd be a nice way to do that if you're willing to do it openly.
Yep.
I'll tell you where we're going next right now, is that we are running this little detector on like 500 sessions that have come in since we rolled out the update that gets the new telemetry. And I'm just going to create those histograms for these main features. And then that's going in a paper for a joint conference in serious games. We'll be submitting that just as like early proof of concept. But then the next move with it, or the direction we were thinking about going, was to just double down on all the video process approach and automate the creation of videos so that every session that night, we also create the video for it, and effectively use know that they'll be slightly out of sync with the telemetry, but they'll be kind of close too, and creating a video-based annotator. So basically you'd scrub the video and you could add an annotation and we would mark the time code of that. And we'd know that it's a little sloppy within how it lines up with the telemetry, but that it's within a second or so, like it's not going to be terrible. And we can use that for doing more of the kind of, educational data mining approaches with detectors and looking for interesting interaction patterns and that approach. So we were thinking, let's go down that route because it's just really simple and we get a lot of value right away. So I'm kind of debating whether or not it makes sense for us to go in engine and build that whole thing now, or just build a Band-Aid version in PHP basically.
Yeah. Like, why do it over video when you've got the engine there?
Well, that from an
graphic interactive system and the capacity to raycast and full knowledge of geometry and everything.
Yep, that's the.
It seems like that would be easier to do than write it in PHP, right?
I don't know yet.
That was my whole original philosophy behind this. It's like I could try to write some weird Python thing to come up with this feature, or I could just use all the APIs that Unity already gives me, and it would take me like 2 minutes instead of days. And so, like, yeah, you got all the stuff there. You might as well just do it in Unity.
I'll take that as encouragement to do it the right way. Because like it's obvious that that's the right way to do it in this next step. But some sort of annotator is definitely the next step now.
I think it'd be interesting to explore. Maybe there's a project in this down the line or something of what kinds of things could be annotated. So not just like this event is happening, but like, could you? I think I've wanted to explore with the replayer, and I haven't picked my replay back up in a while because it's several versions of Unity old at this point. But annotating a property of a state. So like a dumb example that I've used in a multiplayer game I've worked on is like there's a bunch of cars driving around. It's like, how close are they to each other? And I just want to know that all the time. Say I didn't put that in my telemetry. The replayer can do that.
Mhm.
And so you could do, I don't know, like how often are they moving towards the egg or whatever. I can't immediately think of a great dumb example in this, but how would you express that within Unity without having to dump it to code in a way that could run over the replay and give you that metric? Because you could do that. You have everything there. So I think that would be really interesting to explore how you do those kinds of annotation. So not just like a thing happened, which is like a very basic annotation, but like actually drawing on the state that like, I want this and this, and I want to know how they relate to each other. And I want to know it at 90 frames a second go.
Yeah. I was going to say that eye tracking for us, we ended up overlaying the eye tracking data on the game telemetry, and we ended up asking questions like, you know, when is the eye gaze within X number of millimeters of the player particle, which is the main one that the player manipulates. And so we created features that were combined features between the two streams of data. We didn't get to detectors. We were just trying to do that proximity measure to see if that was a useful outcome measure. So I will say the synchronization precision is, I did it by hand for Impulse when we first did that. It was a nightmare before we had the eye tracking data, just to get our labels onto it. Now I think our tool is more qualitative, but you can build quantitative features from the data that you're already collecting and track those alongside of it. So you could create how many times does this happen how many times has this happened in a row? Kind of some feature that you're just seeing. Distance between this and this, and you tell it how to calculate it, and it just does it. That's my goal. That's a goal.
Yeah.
We're not there yet, but we have something we have something that's kind of in progress. But
or think about, for maybe a better dumb example for the penguin case, is like, oh, they seem stuck here in this part of the map. How many times do they come back here? So defining here as a moment in a replay, but then that can spawn out a collider, and then they can go away, and you can check how many times they come back to that. Like, you can do that kind of stuff because you know about the world. And that would be super cool. I would love to work on something like that. And I know this is about helping you and not, hey, I have this cool idea. What do we do?
Well, we're going to be at this for a couple of years still. So we're like funded to basically ask this question of what can we do with VR signals in terms of data mining and understanding affect and knowledge generally. So we've got a very open-ended research project here. So I think somewhere along the line, we're like, well, let's get basic telemetry and replay up and running, and then see where to go from there, like that. And so I think some of these tools, even just coming up with new methods, is in scope for this project. Yeah. Well, thank you. This is, as always, I love it when I'm able to come to these office hours and share a very, very much work in progress. Like, I'm writing this thing up right now for a paper we're going to try to finish on Friday. It's like, I'm looking at data sets that aren't even like totally reliable yet. We're like, we're definitely doing it live right now. So it's cool to be able to share on it, get some ideas of where we should be heading, what experiences people have had.
Well, if you don't manage to make that deadline by Friday, there's always meaningful play.
I see that. We've got some stuff going to meaningful play too. I think we've got at least 2 things queued up for that.
Deadline January 5th for anyone interested. All right. Well, thank you all for joining us again for another open office hour session. As we alluded to, we currently don't have someone signed up for the next session in 2 weeks. So if any of you have a burning thing you want to share with the community, let us know. And then otherwise, we do have 2 weeks after that, in the first week of June, or the first session in June, we do have somebody lined up for that. So we will let you know what's on the docket for next time.
Cool. See y'all around.
Thank you
Yeah.
very much. Here.